Video, we're going to actually divide some expressions. And just again, another reminder, you can multiply and divide anything. You simply multiply or divide the pieces that are alike. So and when I say alike, I'm talking about like the numbers 6 and 12. And also, there's when we say divide, division is synonymous with, if you have a fraction, reducing. So dividing the fractions, reducing the fractions, I kind of use that interchangeably, such as, I'm going to go ahead and write my fraction bar. And when I divide 6 by 12, I'm actually reducing 6 and 12, but they're alike, so I can reduce them. X squared and x to the fourth, we're simply using rules of exponents. You subtract and you have 2 left on bottom. You have 3 y's on top and 1 y on bottom. Subtract, you have 2 y's left on top. So the 1y squared, you really don't have to put the 1, so you could leave your answer as y squared over 2x squared. So again, you're simply combining the things that are alike. Now you do have to be careful of plus signs. If you have a plus sign, the same way with addition, you're actually dividing both of these by 20x. And when I say divide, again, if it's a fraction, well, you might have to reduce instead of dividing. So the first one, 25x squared over 20x. And sometimes, let's do this, sometimes people like to actually split it up like this and actually show that, hey, both of these are being divided by 20x. So the first one, we're going to work with just the numbers, the 25 and the 20. When you reduce it, it leaves you with a 5 and a 4. When you divide x squared and x, you're subtracting, and that's going to leave you with an x. So that's going to be a 5x over 4 plus. And do the same thing with the second one. The 10 and the 20 reduces to a 1 and a 2 when you divide them both by 10. The x and x, when you subtract, you don't have any x's left, so plus 1/2. The next one, again, reminder of what I said. 3 and 4, if it won't reduce, you leave it. Now, what you are going to do with radicals, you can divide root 2 and root 3, but there's a problem. It's going to give you a decimal. So what we're going to do, this process is called rationalizing, and this is slightly different when you're dividing radicals. What you can do is actually multiply top and bottom by whatever this radical is on bottom. So you can multiply bottom and top by root 3, and good things happen. So on top, reminder that the 3 has to stay alone, but you can multiply root 2 and root 3. It gives you root 6. On bottom, you have 4, which stays. Root 3 times root 3 is root 9. Now I'm going to come over here to the side and remind you that root 9 is actually 3. So the bottom is now 4 times 3. And you can multiply that out if you like to, or look what you got. There's no plus sign, so this is fair. This is completely legal. You can cancel those 3's out, and your final answer is root 6 on top, the 4 on bottom. The reason we don't go any further, again, you have a root and you have a number. We do not combine them. The next one, there's a trick to these. Anytime you have a binomial on bottom, now you can't split these. You can only split it like this problem we did up here. You can only split it when you have a single term on bottom. If you have plus signs on bottom, you can do this with radicals. We're going to take and multiply top and bottom by what's called the conjugate. Notice the bottom is 2 plus root 3. We're going to multiply top and bottom by its conjugate, which is 2 minus root 3. Reminder on top, we can do 6 times 2, that's 12. But 6 and root 3 have nothing alike, so we're going to leave it as 6 and root 3. On bottom, you have 2 terms by 2 terms. You have to multiply both. 2, the first term, we're going to multiply by 2. And we're also going to multiply by negative root 3. Now, something special should happen when you multiply by conjugates, and we'll show you that in just a second. Next up, the root 3, the positive root 3, multiplied by 2. Again, notice there's nothing alike, so we leave them as 2 and root 3. However, when you multiply root 3 by negative root 3, that's going to be a negative. And root 3 times root 3, like I showed you over here to the side, was root 9, which is just 3. Now, we got all of our multiplying finished, but reminder, now you can add and subtract when things are alike. So on top, 12 and 6 root 3 are not alike. They're not like terms. However, on bottom, the 4 and the minus 3 are alike. It gives you 1. The negative 2 root 3 and positive 2 root 3 actually cancel each other out. So when you divide each of these by 1, they stay the same. That's going to be 12 minus 6 root 3. That's how you divide radicals when there's 2 terms on bottom. Okay, last one. Now, how do we work with scientific notation? Same thing. You deal with them separately. The 9 and 12 are alike. Now notice these are not plus signs, these are times signs. And if there's multiplication, we don't have to split it up or do anything like we've been doing before. You simply work with the things that are alike. 9 and 12 if you were to divide it, because scientific notation is always going to give you the decimal first. They're not going to give you 3/4 or something like that. They're going to write it as a decimal. So 0.75 is what I get when I actually divide those. And these are also alike. When you subtract 5 minus 10, I'm going to write this as 10 to the negative 5 power, because again, that's the form that we write scientific notation in. However, the decimal, after I did that, that's the right answer, but the decimal's in the wrong place. We want the decimal between 7 and 5. So here's my thought process. Right now, this 10 to the negative 5 is saying take your decimal and move it 5 places to the left. However, I want the decimal here. And if I place it here, instead of moving it 5 places to the left, now I'd have to move it 6 places to the left. So it's going to be 7.5 times 10 to the 6 places to the left. So 7.5 times 10 to the negative 6. And that's how you divide scientific notation.